Hi, everyone. Welcome to another episode of our podcast, Discovering the Architecture Middle Path. As usual, Sanjiva is joining me.
Hi, welcome back. Nice to come back. We've taken too long of a break. And today happens to be Sri Lanka's 78th independence from British colonial rule day. So happy Independence Day as well.
Yeah, so we picked an interesting day with an interesting topic, actually. A hot topic. Everybody's speaking about AI agents, and it's a critical concept as well as a focus area for architects. So we thought of today mainly focusing on AI agents because there are a lot of misunderstanding, misconceptions, and a lot of buzzwords around these AI agents. So we thought of digging deep into that. So Sanjiva, why don't we start with the concepts? And there are like a lot of terminology around AI agents, right? So looking at it, that might be helpful before we are going to get into the details.
Yeah, I think the first thing we should ask is what are agents? Because this word is being thrown around for everything now. And unfortunately, it has a lot of vendors want to be AI first, AI agent companies, so that everything's an agent to some extent. So to some extent, actually, any application that uses an LLM now is being called an agent of some sort. So that's a very broad statement when you bring it to that level. But then there are also specific additional capabilities that makes an agent an agent. And from an English point of view, that is actually very important, because from an English point of view, agent means having agency. And having agency means having the freedom, having the capacity, having the opportunity to decide and act on its own, which of course is not like, traditional way of writing software, right? We don't. So I think that is the key part, that for while the market is playing games with the words, you really, as a technical person, you should be very careful to call something an agent when the underlying thing that you're running has some agency, has some ability to act in a way that was not pre-decided for it by somebody else, right?
Yeah, I think that's a really good definition. Like it's a representative of a human, right? In a way, like taking the decision rather than a human making the final decision. So for me, like I feel it's like a intern with a badge, because you give a goal for that particular intern, and then he or she will have access to certain information, and based on that, they will do that they will achieve that particular goal by working themselves, right? So at the current context, it's like that, not like exactly an employee, but part of the workforce.
Yeah. And I think that brings up an interesting sort of an immediate thing about an agent versus just calling an LLM to do some work. Because an agent doesn't come to the decision on what to do in one step. So if you understand the way generative AI, Gen AI, large language models work, they are simply token predictors. They are mathematically predicting using probability along the ways. That's what makes it not deterministic, what the next token should be. But an agent effectively takes a bunch of things together and goes to the LLM and says, give me an answer to this question, whatever that question is formulated. And then it has a process of reasoning. That is this thing called, like, for example, chain of thought reasoning, which is a way of saying you break the problem down and you reason step by step. So it looks like it's very intelligent acting, but what it's doing is actually just going back and forth to an LLM until it decides, okay, I've had enough. Now I'm going to give the answer. Yeah. So I think that is a very important thing to understand, the difference between a single agent, an agent, versus something that just sends some text to a model and says, generate some more text around it in front of it. Right?
Yeah, I think even a human, when we do something for the first time, the results might be not that great, right? Then we are also going in that particular loop, learning, getting feedback, and then keep on improving. So agents also doing the same thing in that loop that you explained.
Yeah, and that brings to the next. So we're going to try to go through a set of terms that you hear in the world of agentic stuff. so that you know what these mean and have some sort of common sense understanding of what this means. Because I think that's what Asanka and I always focus on. The next big one, of course, is prompt. And there was a whole thing called prompt engineering. Remember in the early days of Gen AI, it was like, oh, prompt engineering is the future job, blah, blah, blah. Now it's all dead. Now it's something else. But prompt still remains. Prompt is effectively the input that you give to the model saying, here's my text. Now tell me what text comes after that, right? And that prompt in the context of an agent, the thing that gives a particular agent personality is the structure of its prompt. If you remember in the early days, people used to say, if you're talking to an LLM, start off with saying, you're an expert in website content development. And now I want you to answer the question. That's the system prompt part of it. That is, you're kind of constraining the information space in which to compute the next set of tokens. Remember, an LLM is something that has just memorized everything on the internet. So if you just give a random set of words, it'll find the next most probable word. But if you constrain it, it'll find the next most probable word in that space. That is why this prompt has multiple components because of that. There's a system prompt that tells you saying, hey, you're an agent that is supposed to know this stuff, right? And then there are supporting things like, okay, what is the role you're playing? What is the actual input the user gave this time? Because I have an agent that is my medical assistant, right? Reads my data, looks at blood reports, so forth, gives me something. So my current prompt might be the new thing I just gave it. Which is like, okay, my heart rate was 120 an hour ago, right? Or whatever. And then what does it mean? And then all that gets connected together to be the prompt.
Yeah.
So I think that's an important concept to understand.
Exactly.
Maybe Asanka, we can go from prompt to the context conversation. Yeah, I think that's the second part of that, right?
Yeah, I think that's the key thing compared to a predefined or scripted workflow, right? Because that's the difference. Now even the example that you gave, you give an input, and then based on the trained data, the LLM will give you output. That's a basic thing that we did. Yeah. Then it extended to a workflow, and then we instructed the LLM to, hey, do these particular actions in this particular sequence. Again, human decided what the LLM should do and execute. So when it comes to agent, to cover all the capabilities that we explained earlier, that's where the context is coming to make that decision. It is looking for the context, and that's the difference or the foundation to make that a decision by itself, and then give the output or a better output that human is looking from the agent.
Yeah. And I think the now in the market, people talk about context engineering now, not prompt engineering. The reason is effectively the prompt was too weak a word to capture the problem that you're trying to solve, which is I'm trying to ask it to predict some characters in the context of this information.
Yes.
And then that leads on to another popular term that came up recently called a context graph. Now, the context graph concept is actually not just about agents. It's a general concept. The idea is actually very, very good, which is that if you look at a system of records, say it's Salesforce or SAP or NetSuite or whatever the thing that you're using for whatever the business function, that has the current state of how much you're manufacturing, how much you're shipping, whatever that, what the order size is, all that information. It might also have the historical state. Say, last week you did this, week before you did that, right? But what it doesn't capture is why the productivity went up, what changes were made, who made those changes to make the output go up from N to M in the last week. Right? So that's what we would call in a normal organization institutional knowledge. We know collectively this is what we're doing, and then we can measure the outcomes. Right? System of record captures the outcome. In WSO2 we use Salesforce. I think about 50, 60 different systems to run the company, and they all capture the outcome. But if you want to know what did we do that time, what happened, we had to go to our human beings and ask what happened, right? So context graphs are trying to capture the context around the actions you're taking. Say, add another person to this particular manufacturing line, or whatever the thing that you're doing. Why did you do that? When did that? When was that? Who did that? That information is the context. So context graph is connecting all that data using a knowledge graph technology and knowledge graph approach, and making that available so that now it's not just the organization knows not only what the current state is and what the steady state was, you also have historical information about why these decisions were done, right? And that feeds nicely into agents as well, because when an agent knows why something is done, it can then again now feeds the context graph information can become context for the agent.
Yeah. So I think it's going to do a dramatical change in the industry, because now with the traditional system of records, it's basically about either a certain assumption or a certain pattern that it follows with the data that we have, right? And this will give kind of more accurate information out of it by looking at the context graph and then going back to history of histories. Even like as a human, we might not remember certain information when we are making the decision, but the beauty of this, it has a more memory, and then kind of get into different level of that graph and then fetch the data. So I think it's going to be a big change, and the data architects and data architecture need to be rethink parallel to building these agents, because without this foundational stuff, agents will be not that effective in the enterprise context.
Yeah. And you use an important word in the middle of that, which I think is also relevant to understand in the context of agents, which is memory, which is, when I use the OpenAI model or Gemini model or DeepSeek model or whatever model I use, it's completely stateless. It has nothing it remembers about you. Now people worry saying, oh, I use a model and it's leaking information. Actually, the only leakage happens if the vendor who's running the model is storing my prompt and the output. But not just by running a piece of text through the LLM, there is no learning that happens in there. So if the vendor gives you a guarantee saying they're not recording your prompt and the output, then there is no leakage, first of all, right? But so memory, so the fact that it has no memory whatsoever, it's completely stateless, means I have to tell it everything every single time. So that's what these chat systems do. They record what you're doing on your side, not on the LLM side, and give the right things back. So memory in a chat GPT like experience is just the last 5 conversations or last 10 things you typed in, what you got back, and so on, right?
Yeah.
In a more complex system, that reads on to what is called RAG. So
yeah, so I think that's the interesting thing now. To do these actions, you need information, right? So I think that's where the RAGs are coming. So the RAGs came first, I think, before the agents became popular. Everybody started writing
and RAG, of course,
applications.
is retrieval augmented generation.
Yes.
Keywords.
Yes. Yeah. So so it is basically the channel for the agents to get information, to do the actions. I think whenever you are designing the agents, looking at the RAGs are really important, from where the data is coming, whether the data is optimized for the agents to make the decisions. All these things are coming from the RAGs that implemented. And then I think there's a slight confusion there as well, Sanjiva, on RAGs versus tools, because people are a little bit struggling to identify what's a RAG and what's a tool, basically.
Yeah, so let's talk about tools and MCP right from there, right? So RAG is really about getting some additional context or additional information to augment the prompt that I send to the model to complete. Right? So retrieval augmented generation. So I go and retrieve some information, and there are various techniques for how you retrieve. Sometimes you embed it and you get back a set of tokens and convert to text, or sometimes you have some other ways, whatever. Somehow you get some additional information I send back. And there's a whole body of work on how do you get RAG to work better than better than not better, right? Tools are slightly different. So in an agent, when an agent executes, agent gets the task that you're supposed to do. It has its internal prompt and all this stuff. And it has a set of tools. Tools are really the things that makes an agent an agent. The fact that it can do something. If it can't do anything, there's no agency. So the tools are the mechanism to do something. And of course, we're talking about software, right? Because this is software. So I need to make a call, some kind of API call, run a process, make a database entry, whatever, something like that. And then MCP, Model Context Protocol, is a protocol, a standard protocol to talk to a tool, talk to another network endpoint with some security, blah, blah, blah. Right? MCP is actually just JSON RPC, which is a very straightforward remote procedure call protocol with a little bit of stuff and convention on top of that. It's perfectly fine. It's good enough to do this problem. And so MCP then becomes the standard protocol. So I can talk to anything now. It's like saying, okay, if I know English, I can talk to a lot of people in the world, right? Doesn't have to be the greatest language on earth. English is not the greatest language on earth. But by speaking English, I can talk to more people. I can talk to a lot of people across the world because it's interoperable. That's what MCP is. So tools give the agent a set of things it can do. And the way that whole loop works is I have created a prompt, go to the agent. In the prompt, I say I have these tools available. Then the prompt says, if you want me to execute one of these tools, please reply back with the following. The LLM then, there's a probabilistic calculation again. Remember, LLM is also very dumb, just a probabilistic calculation. It sends back a thing saying, oh yeah, call this tool. Then I call the tool on my side, get the result, put it back in, and go back again to the LLM. And so that's the back and forth. So recently there was something called OpenClaw. Claudebot became Mortbot or something. Now it's OpenClaw, which is very popular, and it's great. It's a way of running a personal agent basically, and that's what it's doing underneath as well. Now the big power that is there is that it's meant to run in an isolated computer, so it can have full access to a computer, which gives a lot of power.
Yeah. So coming from integration world, it's like modern ESD, like you kind of convert anything to standard flow, right?
Right?
Yeah. That's pretty cool. I think that's some urgency that we have seen in the industry as well, getting the capabilities as MCPs, then like all the LLMs can talk to and get these functions executed. So it's a key area I think architects should take a look. Then I think
we should also talk about the skills concept part, right?
Yeah.
I think that is a second part of that. So the tools are kind of just the tools, but if I want a general personal assistant agent, which is what OpenClaw is, now I might ask it to make a restaurant reservation. I might ask it to reply to my email. Actually, I just had this morning, I was talking to somebody's on the board of the Lanka Software Foundation who has set up OpenClaw, and he replied to an email using OpenClaw. His agent replied basically, right? So the first time I have an actual response from OpenClaw agent. So now this is a general purpose assistant. So if you have a general purpose assistant, they need to be taught how to be specific purpose. That's a skill. So skill is a way of instructing or capturing the instructions to a general agent, saying, hey, this is how you do this stuff. This is how you go and make a restaurant reservation. This is how you go and find a plumber. This is how you go and deploy an email. Those are skills.
Yeah. Even in an enterprise, like it's like that, when there's something need to be done, we go to a specific person because that person got the skill. So I think same thing applies here as well. Yeah.
So here the only thing is that I don't have to go to another agent necessarily. Now that will lead us on to the multi-agent conversation. But it is just saying, oh, I can just pick up the skill. Whereas in the case of enterprise, I can't do nice looking pictures to save my life. So, thanks to GenAI, I can do nice looking pictures now. But otherwise, I had to go to somebody. Now here, the agent can just say, oh, I'm just going to get the instructions and let's do nice looking pictures.
Yeah. Right? Yeah. So I think that leads to look at like these how agents interact with each other, like individual agents like that we call as solo agents, and then kind of the multi-agent environments that we are leading to. because I think everybody started with the solo agents and then figure out that's not the way, right? There can be situations and there can be scenarios you can just stick to a single agent. But with the complexity that we see in the enterprise, and then how you model this stuff properly, and then again going back to the skills, like there can be certain agents have the specific skill. That's where I think these multi-agents concepts are coming.
Yeah. So the multi-agent concept, of course, then is to say, well, if I have one agent that knows how to do something, I have another agent that knows how to do something, how do I get them to work together? And who's going to manage that collaboration? Who's orchestrating the multi-agent sort of, play that's happening in the world, right? By the way, these terms are not new. I was a grad student from 89 to 94, and my group had another person who was working on agent-oriented stuff. And we used to write papers on multi-agent systems back then, early 90s, right? So these are concepts that have been around. But an interesting aspect of agents which are powered by LLMs is that because these agents are not single function inherently, the skills concept kind of allows an agent to change personality. So there's a little bit of a moving away from multi-agent, agent orchestration. There's the general trend right now is don't go there unless you really, really need. You can just use skills and get one agent to do all the things you need to do. But it is, and there's of course a protocol also called A2A, agent to agent, which is kind of an extension of MCP to allow. And there's something called agent cards, which is a way of an agent declaring what it's capable of doing. Just like MCP has a tool description mechanism. So the pieces are there, but my recommendation is right now don't go build a multi-agent system except for experimental purposes.
Yeah,
it's probably too much power to orchestrate, right?
Exactly. I think going back to basics, right? Like use a iterative process, like start from one, and then you have to iteratively getting into these domain-driven designs and all these kind of fundamental concepts, and then get into the multi-agent at some point.
Yeah, and those concepts don't go away, right? That's the most important thing. Everything we talked about from the beginning of this podcast about how you do iterative approaches, how you do decomposition, those are still exactly the founding principles on which you solve every problem.
Exactly.
This is just yet another tool.
Yeah. So I think then the next thing is like where these agents fit in, right? Like there are like multiple scenarios. So one is basically acting as a client in the enterprise. And then the next thing is about become a glue basically as a orchestrator within the enterprise, and then doing certain activities. Those are the two main things that we have seen at the moment.
Yeah, I mean, at some point we will get to the point where, now I mentioned it was about some work we're doing with that, and the person replied, the agent replied. Now, if I had wired up my agent to it, my agent can reply to that agent, and things can happen because we had to register something somewhere, right? That agent can go and do the registration now, right? Yes, why not? So it's basically we are going to get to some point where I have an agent. Asanka, you coined the term digital double for this a long time ago. Not in the context of agents, but prior to that, right? A digital double, my agent will talk to Asanka's agent, and will talk to the people operations agent, will talk to the travel operations agent, and they will get things done. And maybe send me a final update saying, while you're sleeping, we took care of all these things for you, right? And here's what you need to know. The rest, if you want, you can click on these links and find out. But TMI for you probably, right? So too much information for you. So, and the key thing is agents can fit in very broadly. Do we want to get to that stage? For example, in government, a lot of government work that I as a citizen interact with government is involved with following processes defined by the government.
Yes.
And get an agent to do it. And on the other side, there are human people who are implementing those processes. They make judgment calls. But in fact, judgment calls in government decisions are governed by the laws and regulations. So not actually judgment calls, sort of interpretation calls, which an LLM can do. So, but then this kind of leads on to that extreme scenario of saying, do you really want to go to that extent? And that brings up the question of what are the risks? How do you manage this? So I think again, we believe in this sort of iterative approach, right? Crawl, walk, run, make it work, make it better, make it great. So going all the way to the other end, say, okay, we don't need anybody, we can just make this all work magically, is a formula for failure, for disaster, not just failure.
Yeah, I think now that the risk and those are critical because there's a lot of autonomy for the agents, right? Even an enterprise, we have policies, we have compliance requirements, and then there's people operations. So traditionally we call as HR to manage people. Similarly, we need all these concepts baked into agents as well to control the agents. And I think one important thing there is these agent ID kind of concepts are critical when it comes to having that framework properly.
Yeah, I mean, all the, you need a governance framework, you need to have the guardrails, you need evaluation. There's a bunch of stuff that we didn't talk about that you need. And there are tools coming up for that. Different vendors have different answers for it. And we are still very, very early stage, right? My dogs are barking. I hope this is doing reasonable job in my translation. Otherwise, we'll have few dog barking sounds along with the podcast. But I think all the pieces are falling into place. Okay, I need to stop the dogs so we'll have to cut this part out of Asanka, okay?
Yeah, that's fine. Yeah.
Hey, Jojo. Cute, come here. All right. So so the guardrails and all these mechanisms that you need in order to be able to operate an agentic system without it kind of causing all kinds of damage. I will just give one example. I think there was a story, I can't remember, a Canadian airline, I think. The agent that was replying to some query gave some wrong information. And they had to pay up. I can't remember, it was some number of free tickets or something like that. It wasn't a massive hit, but there's legal liability. If the agent is representing me, then what it does, I'm liable for. So there are all kinds of things you need to have in place before you go and say, sure, go and represent me. And it's a random probabilistic event. When you understand what happens underneath, you realize there is no thoughtful operation here. This is just all, linear algebra and matrix multiplying and numbers. It looks really nice, but that's all it is underneath. No heart and soul.
Yes. Yeah. So I think there are no silver bullets, and our podcast is not about that as well. So these are like our findings and then our experience. So I think architects, they should rethink about how they thought about earlier, as well as the sticking to the foundation is the key. Only I think the main difference, Sanjiva, like think or treat agents as kind of the first class citizens in the enterprise is the biggest mindset change that they have to do. And then the second thing is about designing everything. Now we spoke about the data layer on the context graph and so on and so forth, knowledge graphs. So how they think these supportive things for the agents and design it in a way that you can support it, APIs and all these tools that required. And then again, I think you made a really good point on start small and then iterate, because going for a big bang release might not work, because you need to release these things quickly, because business is looking at agents in action and then providing some value to the enterprise. So those are kind of my three things that I thought architects should look at.
Absolutely. And I think the same principle we always advocate, which is understand the fundamentals without the hype, without marketing gop, without AI slop, and understand from first principles, what is the actual problem this solves? Once you get that, you can figure out how to build value. And as Asanka said, boards to CEOs to business leaders all want to announce, oh, we are running agents that do XYZ, and this is how much we are saving money and blah, blah. So you have to show results. You can't wait forever. And our approach is not to suggest you wait, but to take things incrementally, always.
And it is a very interesting topic, and we can chat another 30-45 minutes very easily. But I think we should keep some of these concepts into the next topic that we are planning to speak about, how an agentic enterprise looks like, and what is the role of an architect within the agentic enterprise, because today is mainly about the inner architecture of the agent, and we can take a look at the outer architecture and how it fit into the enterprise during our next session.
Yeah, and how to shape the existing enterprise, because nobody starts greenfield, right?
Yeah.
How to shape the existing enterprise to be able to become an agentic enterprise.
Exactly.
And that's kind of what we are working on across the board. So yeah, look forward to the next session.
Yeah, and that's a North Star for everyone at the moment, right? So how we can help in that particular journey. Yeah, so thank you for joining us, and then we'll come up with this interesting topic and cover it during our next episode. So thank you again.
Thank you.